Let us start looking into the data mining class by the introduction. So the first chapter is about the introduction to data minings. In this chapter, let us take a look of what kind of the things that we are going to learn throughout the class. This class is an introduction to a young and promising field called data mining and knowledge discovery from data. Data mining is only about 20-30 years old. Compared with math, biology, chemistry, those kind of courses or the majors, data mining is obviously super young. Everything is changing. The things that I learned compared with what we have looked right now is totally different. So what motivates the data mining? This is the outlines that we want to look in this chapter, starting with the motivation, and we want to discuss what is data mining. And finally, we want to look into what kind of patterns or algorithms that we will learn throughout the semester. So let's start with the motivation. Necessity is the mother of the invention. So because the data comes out quickly, compared with 10 years ago, the data that we are processing right now is way bigger and abundant compared with the old times. The explosion growth of the data, think about the transactional data, think about the YouTube, think about the MP3 songs and videos and maps, everything grows so quickly. So data collection and data availability has been improved a lot, not to mention the storage spaces are much cheaper compared with the old times. So the major resources of abundant data become untouched, and we want to find what kind of information that we will be able to retrieve from it. And that is what we call the necessity. So data collection and data availability. Right now, there's everything is related to computers. Literally everything. So when it comes to the computers that storing or touching those data, they can be automatically saved and stored in all kinds of formats. So automatic data collection tools, database systems, webs, computerized society, everything is so easy to collect the data. And those sources including the web, e-commerce, transactions, stocks, etc. And these are only considered as traditional databases. These are the type of things that we discuss in our database class. Now we have more different kind of data, including science, bioinformatics, chemical informatics, geography. There are so many different things that are related to science, has lots of data available. Not to mention society and everyone has been creating different kind of data, pictures, videos, songs, everything, cameras. So all of these contains huge amount of data. And the question is, how can we find information throughout those data? If you can find some information from any kind of these things, they will be actually pretty interesting and useful, and maybe directing old things into new directions. And therefore, we are drowning in data, but starving for knowledge. And in these times, knowledge is future. So how can we find the future from the large amount of data? It's always a very challenging and interesting question. So if we look into the history, in the 60s, that's when the computers are starting. And remember, this is not long ago. This is only 60 years ago. starting with the data collection, database creation, and creating some networks. And in 70s, they starting have the concept of the relational data model, relational DBMS implementations. And in 80s, we have relational database management systems, such as Oracle, SQL, those kind of things that we learn in our prerequisite class, which is the database class. And then it has a lot of application-oriented DBMS. So these are considered older informations. And once we get from that stage in 90s and 2000s, we start looking into the idea of the data mining, data warehouse, multimedia database, and web databases. And when it comes to the year 2000s, which is only 20 years ago, we are starting to look into the stream data management and mining, data mining and its applications, web technology, etc. And it is when data mining become a major topic in computer science. And from 2010 to 2020, which is nowadays, data science has been the dominant term in the field. So this data science is basically data mining that incorporates all different kinds of things with a very specific application domain. We will try to look into this in like advanced topics of the class. But data mining is like the backbone of the data science area that make it possible to find information from large amount of data. So what is it exactly, the data mining? Data mining is basically extraction of interesting. And how do you define interesting information? Interesting means it's not trivial. It's not like everybody knows it. Implicit, previous unknown, and potentially useful patterns or knowledge from huge amount of data. So basically, data mining is try to find huge interesting pattern from large amount of data. One of the most famous example of this one is that in Walmart, and this is true story, about 10-20 years ago. In Walmart, they try to find data mining interesting patterns from their transactions. Obviously, Walmart is probably having the largest amount of transaction data in the world. So they try to look for some interesting information. And what is the non-trivial, implicit, previously unknown, and potential useful patterns that they found? They found on Friday, especially afternoon, people who buy diaper will also buy beers. That's something very interesting. So how can diaper and beers be connected? And therefore they try to dive into the logic behind that and understanding it's Friday and husband are probably asked by their wives to go grocery stores after the work or from their home to buy some diapers that they need for the next week or two. And probably in the idea of sort of revenge or something or relaxation, that they want to buy something that they are interested in. So they actually purchase some beers together with the diapers. So that is one of the most interesting knowledge that I found. To find this kind of information, we actually have one set of algorithms to look into it. That's what we call the association rules. So we will be able to look into how can we find these kind of things. And not to mention, this is widely being adapted in Amazon or any e-commerce that when you are looking into the camera, they will have a recommendation says that you may also interested in batteries, memory cards, different lenses, etc. So that's how they will be able to use the information to generate the revenues or attract more people. So data mining is actually a pretty interesting name because think about this. The data mining is you try to find the information from large amount of data, but if we change data into gold mining is indicating you want to find gold from some mountains or some caves, but gold is something you want to find. In here, data mining, it is not the data that you want to find. It is actually the knowledge you want to find. So a proper name for this kind of idea is probably like knowledge discovering, etc., instead of data mining. However, since people are using data mining all the time already, it is like one of the most dominant terms. And that's why we are saying data mining might be a misnomer. So alternative names including knowledge discovery in database, knowledge extraction, data pattern analysis, etc. are probably a better name than data mining. But you know, this is the name of the class, and that's what we were going to stick into. This slide shows you the whole process of data mining or knowledge discovery process. And this one is actually also like a snapshot of what we will learn throughout the whole semester. And therefore, this is a very important one. Starting from the left lower corner, this is where we look at the data, like in the raw format. So we may have different sources of the data. Think about this, like Amazon. One box over here can be Amazon United States. The other one can be Amazon in Japan. The other one can be Amazon in UK. They are all Amazon databases. However, there's going to be a lot of differences, including like currency, including like shipping methods, including like laws. So how would you combine all of the data that you have into a place that can fully summarize those information? This stage is very difficult already. This is what we call the data pre-processing step. You need to clean the data, you need to integrate the data, you need to make sure all different kinds of things can be converted, for example, like currencies. And then what we can form is what we call a data warehouse. In here, all kinds of data are being cleaned and organized in a very nice way so that we will be able to extract the subset of the data that are clean and precise already, so that we can take that task relevant data, perform data mining on this area. The information that we found may be good or maybe pretty boring. So we need a step to evaluate the results, and then after the evaluation, we only get the good quality of the informations, good quality of the patterns, or what we call the interesting patterns, transform that into the knowledge. And of course, all the steps can backtrace into different stages of it to get a refined results or corrections over there. So you can see that this is like the whole process of the data mining or the knowledge discovery process. We will have one chapter talking about the data pre-processing stage. We will have one chapter talking about the data warehouse, and then we will spend most of the time discussing different kind of algorithms in the data mining and how do we evaluate it, how do we transform that into knowledge. And that's what this is like the whole process that we will learn throughout the whole semester. Like I said, we will have first 4 steps as the data pre-processing, starting to clean the data, remove noise and inconsistent data, and then we want to integrate them together. So combine multiple sources, and we want to select the relevant data that we are interested in, and then transform data into appropriate format for the data mining. So you can see the first 4 steps are preparing for the data mining process, and we need to use the evaluation to look into the quality of the patterns that we retrieved and then transform that into the knowledge. Again, like I said, pre-processing is step 1 through 4, and although data mining is only one step in the entire process, this is like the main engine of the whole process, and is essential one since it uncovers hidden patterns from the evaluation. But you need to understand that if you don't do pre-processing step correctly, the data you have is not what we call cleaned, and it would be very difficult to apply data mining on uncleaned data. So based on this view, the architecture of the typical data mining systems may have the following major components. It would require database, data warehouse, World Wide Web or other information repository to store the data, and we need a database of data warehouse server to store the data to get the cleaned data that we want it to be, and we use the data mining engine or algorithms or the programs to look into that, evaluate the results, and then present those informations to the users who are interested in. And therefore, and see that this is like the visualized graph to talk about the previous slide. We have the source of the data. We collect all of them together using the data mining engine, evaluate the results, and in here, this is the knowledge base that we need to go back and forth, refine it, and then provide those informations to the users who are interested in. Using the similar concepts, you can see the different role of the peoples that are working on each stage. For the basic areas of the data collection, this is more like a DBA, database administrator's job. They try to query the languages, they try to refine, clean, process the whole data. And then when it comes to the data mining stage, this is more like a data analyst people who try to look into that. And once we are mined those informations, evaluated, and thinking about how to present those information, this is more like a stage of a business analyst. And when it comes to the decision making, it's going to be like an end user, probably the manager or the CEO, try to use find information to make changes in the business. So this is like the whole process of the data mining, and these are the role or the people associated with each stage. So data mining is an idea that connects a lot of different things. It has the database technology, machine learning, pattern recognition, algorithm, other disciplines. So this is like the domain knowledge is related to the data that you want to process. If you are working on a business data, you need to have some business knowledge regarding to it. How do you present those informations? And of course, all computer science algorithms is related to statistics, especially the data mining areas. So data mining, what kind of informations that you would be able to find? So from the source, relational database. This is like the basic data that you may collect, and you probably be familiar with this data because this is the data that I use in my database class. So this is more like a relational database that comes from the original or the more old school type of the data that we are looking at. And then we need to transform that information into the data warehouse, and we want to make queries and then finding the information that we are interested in. So transactional database is like the most basic versions of that. Advanced database and information systems, including object-oriented database, temporal database, spatial database, text and multimedia database, and World Wide Web. There's a lot of different things that are interesting and can be converted into computer processable data. Like in my own research, I'm trying to look into the wine reviews, which is stored in human language format. And how do we convert those human language format into the data that computers can process that involves in natural language processing? So that's a different type of the source of the data. We will have some time to look into that. And throughout the semester, you will also have the opportunity to look into some bioinformatics data that I have been working on. One of the examples is like yeast. Try to find what are the longevity genes in the yeast. So different kind of things will be introduced to you guys regarding to the different source of the data. So finally, what kind of patterns can we mine, or what kind of patterns that we are expecting to learn? In general, data mining tests has two different categories. One is what we call a descriptive and predictive. So descriptive mining tests characterize the general properties of the data in database, which means we try to summarize what we see of the data. The other one is called a predictive mining task, performs interfaces on the current data in order to make predictions. So one is describing the data, the other one is making the predictions. There's also another term that we use over here. One is called supervised learning, the other one is called unsupervised learning. Supervised learning is indicating that there's a label. For example, saying that this patient has cancer or this patient is free from cancer. So having cancer or not is like the label that we are looking at. If we are looking into this kind of data, this is what we call supervised learning. And most of the time, supervised learning is what we use for making the predictive models. We try to predict when a new patient comes in, does this patient has cancer or not. On the other type is descriptive mining. For example, say a group of patients that they all have cancers. So the cancer is no longer a label because all of them have cancers. So we try to group them into 3 groups. Try to see that group A might be the minor scenarios. Group B might be having some severe situations. Group C may be some special cases. These are the descriptive models that we are looking at. And therefore, if we separate those kind of things, different algorithms into chapters, you will see chapter 4 is about mining frequency patterns, associations, and correlations. So in this one, the first type of the algorithms that we will touch is called frequent patterns, are patterns that occur frequently in data. The example that we can see is the beer and diaper example. And another case is that people who buy computers may also buy softwares. So these are the association analysis that we will learn in this class. So that's one category. Chapter 5 is talking about classification and prediction. This is the typical supervised learning that we are talking about. So saying that we know a label over there, saying that a patient has cancer or not, and we want to use what we call the training data set, build a model. So you can see that there's one type of model, another type of model, another type of model, to create some knowledges in there, so that when new patients comes in, we can use the model that we built to make the predictions. So this is what we call the classifications and predictions. We then will look into cluster analysis. This is the typical unsupervised learning. So in general, the class labels are not presented in the training data. Simply, they are not known to begin with. And this is actually more like humans to learn the things. These objects are clustered or grouped based on the principle of maximizing the intra-cluster similarities and minimize the inter-class similarities. In other words, if you put things that are in a cluster, all the things in the cluster are very similar. And if we compare cluster and cluster, they are we try to make it as far as possible. So that is what we want to do in what we call the clustering analysis. This is an example of it. So you can see that based on the whole data set that we have, we may be able to group that into 3 different clusters. And all the things in the cluster are similar to one another. However, you will have another cluster that may be something very special. And there are some points that they are not within a cluster. That's also possible. And what we're going to see that can be separated into another chapter. Consider them as outlier analysis. And these are the things that we will be able to see. If we come back to this slide, let me give you an example. Saying that you work for a Toyota dealer, a car dealer, and then saying that for the x-axis is the age, the y-axis are income. So this is actually a very easy, understandable two-dimensional data set. So you can see that you group this group people, they are young, or having somehow this area of the income, not too high, not too low. This group of people are older people with lower income, and this group of people are like have elite incomes. They are older, but they have a lot of high incomes. So saying that you are a manager and you want to promote some of your cars, how would you use this knowledge? That's something I want to ask you. Think about this. If you've seen this, saying that you have some luxury cars, Lexus, for example, a new model comes out, you probably want to use this group of people as your target instead of the other two. And for this group of people, they have a relatively lower income, then you might want to promote your Corolla to them. And versus like these are the younger people, they have pretty good income. So if you have some Scion or some sports cars like FRS, then they may be interested. And therefore, clustering analysis is the way that you group similar things in your data set. You try to find the information, try to use those information. This is what we call a clustering analysis. And finally, outlier analysis, indicating that these dots that are outside of the cluster, they may be noise, we can ignore them, or they may be something useful. For example, you can see that this dot, this is some people that are young, however they have high income. So how would you want to use it? It's going to be something interesting. And that's why the outlier analysis is also part of the data mining process. So most data mining methods discard outliers as noise or exceptions. However, in some applications such as fraud detection, the rare event can be more interesting than regular occurring ones. And therefore, this is the introduction I want to show you about what we are about to learn in this exciting semester.